Hello and welcome to this video about the difference between an F-test and cosine similarity. If you're studying statistics or data analysis, you may have heard of these two concepts, but don't quite understand the difference between them. Or maybe you never thought they are similar and had no solid understanding of their similarities. That's where this video comes in. We're here to break down these concepts and help you understand the difference between them, so let's get started. First, let's take a look at the F-test. The F-test is a statistical test used to determine whether there is a significant difference between the means of two sets of data. The F-test is used to compare the variability between two sets of data, and it helps to determine whether the difference between the two sets is significant. The studied samples are called populations. They need not be equal in size, but we build them so that we expect that a distribution null hypothesis is true about them. Namely, we suppose that the two populations have the same variance relative to equal means. The F-test shows if we have good reasons to believe that it's not the case. To conduct an F-test, you need to calculate the variance of each set of data, and then divide the larger variance by the smaller variance. In this case, we suppose that you found two population samples that have the same mean value for the studied variable x. The result of the F-test is then compared to a critical value from a statistical table, to determine if the difference between the two sets is significant. This critical value depends on the number of samples from each population, called the degrees of freedom, and the significance level that your field of study requires. These data are used in tables to retrieve the critical value, that you then compare to the F-score. If the F-score is higher than the critical value, then the null hypothesis is proven wrong. You can also calculate the p-value in this case, to show off in your scientific paper about your findings. The p-value is the level of confidence. The smaller it is, the highly likely that your result is strong. A typical value is below 0.05. The F-test is used when you have two sets of data with normally distributed variables, and you want to compare the means of the two sets to see if they're significantly different. More appropriately, you have reasons to believe that the means are not different and you expect the F-test to prove you wrong. It's important to note that the two sets of data are supposed to have equal variances, as the F-test assumes equal variances between the two sets. In terms of sample size, there's no hard and fast rule, but it's generally recommended to have a sample size of at least 30 in each group, to get accurate results from the F-test. The sample sizes are called degrees of freedom and they can be different. They are useful for calculating the critical value for the F-score. One of the major limitations of the F-test is that it assumes that the two sets of data have equal variances, which may not always be the case in real-world situations. In such cases, alternative tests, such as Welch's t-test, should be used instead. By assume, we mean that we expect not to find a difference between the two populations, since our criteria for building our samples are random and arbitrary, at first glance.
I've always struggled with understanding the F-test, but your explanation just made it click.
That's great to hear. We're here to make learning these concepts as easy as possible.
Definitely. I'm really enjoying this video.
Awesome. If you're interested in learning more about data analysis and mathematical concepts, be sure to hit the subscribe button.
I will. I don't want to miss any of your future videos.
Excellent. We have a lot of exciting content coming up. I can't wait for you to see it. Cosine similarity is a measure of similarity between two non-zero vectors in a vector space. Why is that important? It means that the data points are labeled and ordered. In Python programming jargon, this means that we are looking at an ordered list, not a set. It's important to note that cosine similarity is calculated in a vector space, where each dimension represents a feature, and the components of the vectors are ordered. An example of such features are scores for specific criteria, comparing two movies based on respective specific genre. Cosine similarity measures the cosine of the angle between two vectors, and it ranges from -1 to 1, with 1 being a complete match, and -1 being a complete mismatch. To calculate cosine similarity, you need to calculate the dot product of the two vectors, and then divide it by the product of the magnitude of the vectors. Cosine similarity is a commonly used metric in text classification and information retrieval, as it allows us to compare the similarity of two documents or text pieces based on their features and ordering. In cases where the components of the vectors are all positive, The value of the cosine similarity ranges from 0 to 1 and denotes a factor of collinearity between the two vectors. Now that we have a basic understanding of both f-test and cosine similarity, let's compare the two. F-test is used to determine if there is a significant difference between the means of two independent sample populations. In other words, it expects that the variances of those means are similar and looks for a reason that it's not the case. Cosine similarity, on the other hand, is used to measure the similarity between two vectors in a vector space. When it comes to the criteria for using each method, f-test requires independent data points and a large enough sample size to ensure reliable results. Cosine similarity, on the other hand, only requires vectors with ordered components in a vector space, and there is no minimum sample size required. In the case where the components in the vector space are all positive, the cosine similarity score will always be between 0 and 1. A score of 1 means that the vectors are exactly similar, and a score of 0 means that they are orthogonal or have no similarity.
I've been searching for a video that explains the difference between the f-test and cosine similarity, and I finally found it here.
Glad we could help. We want to make sure our content is meeting your needs.
It is. I appreciate how well you break down these complex concepts.
Thanks. If you have any feedback or suggestions for future topics, please leave a comment below.
I definitely will. I'm really impressed with the quality of your videos.
We appreciate that. We're always working to make our content even better, so your feedback is incredibly valuable. While both f-test and cosine similarity have their strengths and limitations, it's important to note that they both have situations where they are not applicable. For instance, the f-test assumes that the data follows a normal distribution, and if this assumption is violated, the results may not be reliable. Similarly, cosine similarity is calculated in a vector space, so it's not applicable for non-vector data. In such cases, alternative tests, such as the Mann-Whitney U test, can be used instead. This test is particularly useful for comparing two independent samples with non-normal distributions. Don't worry, we'll delve deeper into the Mann-Whitney U test and explain it in more detail in a future video. That is, if you request such a thing in the comment section. Thank you for watching this video on the difference between f-test and cosine similarity. If you found it helpful, make sure to subscribe to our channel to stay up to date with more content like this. By subscribing, you'll never miss a video and have access to our exclusive content. If you have any questions or topics you'd like us to cover, leave a comment below. We'd love to hear from you and help you expand your knowledge.